All right, now let's imagine fertilization does take place. First of all, fertilization typically takes place in the oviduct, fallopian tubules. All right, so fertilization takes place. Then what happens? Well, back up again. Fertilization takes place during the luteal phase of the ovarian cycle, which is the secretory phase of the uterine cycle. So that's when fertilization will take place. All right. Fertilization takes place, and it takes 3 to 5 to 7 days or so for that fertilized egg, and we call it a zygote, to develop fairly rapidly, undergo cellular division into a blastocyst, and for that blastocyst to find its way down into the cavity of the uterus and then implant into the wall, uterine wall. So let's say implantation was successful. That is, the outer cell mass develops those trophoblastic cords that invades the uterine endometrium, and we start developing the early fetal portion of the placenta, the chorion. That structure will start producing a peptide hormone. So the placental precursor starts producing a peptide hormone, and that hormone, human chorionic gonadotropin, HCG, is identical in its peptide structure to luteinizing hormone. Now this is really important because the corpus luteum, the source of progesterone, corpus luteum in the ovaries, is doing itself in. Its ability to produce progesterone means it's also limiting the ability of the anterior pituitary hormone to make luteinizing hormone. So there's a negative feedback going on between the corpus luteum and the anterior pituitary. We need progesterone and high levels of progesterone to maintain the integrity of the uterine endometrium, to allow for the implantation, pregnancy to continue. Human chorionic gonadotropin, identical in structure to luteinizing hormone, now becomes the primary stimulus for the corpus luteum to continue to produce progesterone. The chorion, the production of the HCG by that structure, does not respond to negative feedback. It does not shut itself down to the high levels of progesterone. The anterior pituitary does. So this HCG is critical to maintain the functioning corpus luteum, or the corpus luteum of pregnancy, it's called. In fact, we call this the rescue of the corpus luteum. That is, the human chorionic gonadotropin assures that the corpus luteum is going to continue to make significant progesterone beyond day 14 of the corpus luteum life. And in fact, the corpus luteum of pregnancy extends well beyond day 14. Now, this progesterone, again, absolutely critical to maintain the integrity of the uterine endometrium and allow pregnancy to occur. The HCG is necessary for about 9 to 10 weeks or so after implantation. Beyond that point, the HCG probably isn't necessary. In fact, the corpus luteum probably isn't necessary beyond 9 or 10 weeks of gestation, because the placenta becomes fully capable of producing progesterones and estrogen. Eventually, the estrogen production by the placenta is going to well outpace the progesterone production. And by eventually, I mean late in gestation, with the estradiol levels being extremely high, and actually estriol, a new estrogen, but the estrogen levels being extremely high relative to the progesterone. And with some critical ratio of very, very high estrogen to progesterone develops, we see some interesting changes in the uterus. Notably, we see the increase in oxytocin receptors, and we see the formation of gap junctions between individual smooth muscle cells of the uterus. This sets the stage for the uterine smooth muscle to become very reactive to oxytocin. And with oxytocin binding to cells, stimulating contraction, these contractile events spread throughout the uterus because of the presence of gap junctions. So typically this is late in pregnancy. How is the oxytocin stimulated for production? Well, as the fetus grows and grows and grows and descends a little bit further and further and further down into the uterus, the fetus starts to stretch the cervical aspect of the uterus. Sensory neurons in this region relay information back to the hypothalamus. And with continued stretch comes continued relay back to the hypothalamus. Hypothalamus responds by increasing more oxytocin. More oxytocin more uterine contractions, more stretch on the uterus and displacement of the uterus, more oxytocin. This is a classic example of a positive feedback loop. So, eventually, of course, we break this positive feedback loop with delivery of the child.